All right, when we're talking about rational functions that are a polynomial divided by a polynomial, if my numerator has the polynomial a to the n, x to the n as my leading term, and then it has some other terms that I don't care about, then the leading coefficient is a sub n, and the degree of the polynomial is n, right? That's the power on the exponent, or on the term that has the highest exponent. In my denominator, we're going to call it a sub m x to the m, and then there's some other terms in that polynomial, but I only care about the leading terms. Okay, so the degree of my numerator is n. The degree of my polynomial in the denominator is m. So we decide what the horizontal asymptotes are using those degrees. If n is less than m, so the degree of the numerator is less than that of the denominator, we get a horizontal asymptote of the line y equals 0. So basically the x-axis. If the degree of the denominator I just wrote that wrong. If the degree of the numerator is greater than the denominator, there is no horizontal asymptote. Our third case is if the degree of the numerator equals the degree of the denominator. We get a horizontal asymptote that is a ratio of the coefficients of the leading terms. So it's like we have just this part of it, and if n and m are equal, then that would go to 1, and we just get the ratio of the coefficients. All right, so we want to find the horizontal asymptotes. My first function is g of x equals 6x cubed minus 10x over 2x cubed plus 5x squared. So what I want you to do, because sometimes in the homework they try to trick you and they won't necessarily write the terms as the highest exponent down to the lowest, is go look at both your numerator and your denominator separately and get rid of anything that isn't the highest exponent. So 10x to the 1 is not the leading term because 6x cubed has a higher exponent. And 5x squared is not the one we're looking at because 2x cubed has the highest exponent. So the degree of my numerator is 3, the degree of my denominator is 3. So when I go back here, that is situation number 3. The degrees match. I have a horizontal asymptote that is the ratio of the coefficients. So y equals 3 on the graph would be a horizontal asymptote. All right, let's try another one. My function is h of x equals x squared minus 4x plus 1 over x plus 2. So the degree of my numerator here is going to be 2. The degree of my denominator is going to be 1. So the degree of the numerator is greater than the denominator. Go back to our rules here. That's case number 2. We have no horizontal asymptote. All right, of course we need to do our last case that we haven't gotten to. My function is k of x equals x squared plus 4x over x cubed minus 8. So in the numerator, x squared is my leading term. I don't need the 4x. In the denominator, x cubed is the leading term. So the degree of my numerator is 2. The degree of my denominator is 3. So that is case number 1. The degree of the numerator is less than the denominator. We get a horizontal asymptote of y equals 0.